A new topic is what we call functions and relations, and it's really about being able to do graphs and be able to describe those graphs. And because a lot of the time in the course, we're going to be expected to put graphs and use graphs, and we've got to have some understanding of what the graphs are going to mean for us in what we're trying to do in our problems. So we have some terms we have to learn. The first one is what we call a relation. So the idea of a relation there is any set of ordered pairs. So basically values of x and y that will be connected by some rule. So if we have a look at these numbers here, the rule would be the second member of these pairs is double the first. So we could write the rule as y is equal to 2x. If those are x values, those are y values, then we get an equation of that relation. So there's a relationship that exists between what happens to the first number as to what and what we do to the first number to get the second number. So that's what we call a relation. It's basically looking at the idea of a rule. So when we do the graph of that relationship, we get a straight line. Y is equal to 2x is a straight line. So what we have there is the idea that the x values we take are what we call the domain. So all possible x values would be the domain of the relation, and in this case there's no restriction, so it could be any real number. We could write it like that. It's all fancy R, but x is all real will be fine. That little symbol there means belong to, so that means belong to the set, and that's a set of real numbers. So that's what it means there. So, or basically means x can be any real number. The y values we take here are what we call the range. So there's another term, the range. So again, range can be any real number. So not a problem, take any y value, any x value. There's no restrictions. And that's really what we're after in this case. How do we start describing our relationship here and our graph is that it can be any x value, it can be any y value. There's no restrictions on our domain, the x values, the range, which is the y values. So, and that's how we wanted to start to describe our graphs and describe our relationships that we get between y and x. Is there restrictions on our domain and range? So that's there's the first few words there and terms we need to know. So have a look at these ones. We've got another one, function versus a relation. Now we saw relations when we talked about our relations there, but all these ones over here are functions. All these ones over here are relations. Now, if we compare and contrast it again, sometimes we can have all x values or xy values. Like this one can be restriction in our y values. This one's got a restriction in our x values, and no restriction on our y values. A semicircle compared to a full circle, which is a relation. 3x plus 4, sorry about that, as opposed to x squared plus y squared equals 9. So that's a relation, that's a function. There's a relation, that's a function. What is the difference? So and that's what we wanted to see. What's the difference when some things become functions? What are relations? So we can compare and contrast and try and see what's the same, what's different. So we still see that there's a rule that's relating all of them, whether it's a relation or a function, but there's a few restrictions that we have to face if we want it to be a function. And what is that? So a function is a relation, but it's a special kind. And it's a situation where every x value must have one and only one y value. So basically we're saying for each x value there's a unique y value. So if we look at the back end of these ones, for each x value here there was 2 y values. So that's why it gave us a relation where because of the semicircle there's only one y value for the x value. All these ones have one y value for every x value, but the x values here have 2 y values for every x value. 2 y values for every x value, only 1 x value for every y value. So that's where we got that's what we get there. So there's our functions, and we see these vertical lines occurring there. Now this leads us to a test to see whether something's a function or a relation. It's what we call the vertical line test. And basically, if we can draw a vertical line, so straight up and down vertical line, and we only hit, if we hit our curve we've got twice, it's not a function, it's only a relation. Because if we do that, there's, for any x value, there's going to be 2 y values. So there's our function there, because we can do it, put a vertical line anywhere along that graph, and it only touches it once. Here though, we get a horizontal line and it touches it in 2 spots, which means it's not a function. It must be only a relation. We can only call it a relation. It's not that special one we call a function. So in these ones, are these functions a relation? It's a relation. It's a function because we can put a vertical line anywhere and it only cuts it once. This one, a relation, because it cuts it at 2 points there. If I did it there, yeah, it only cuts it once, but it's at any point. So even if it was only those last 2 points lined up and we cut there, it would be a relation. If it missed, then it's a function. So this one, function, because open circle means it's not equal to there. So even at that point, there's only 1 point that's equal for every x value. There's only 1 y value. So that one would be a function. This one's a function, even though it's a really weird looking one. It's what we call a piecemeal function, because it depends on our values of x. We take different values of we take different expressions for y. So that's a function there. So what we're trying to do in this in the course here in the 2 unit is to try and graph these functions and relations, and we want to only show essential features. In the junior courses, you were used to getting tables of values and then plotting them up and sketching out curves. That's not what we want to do here. Okay, that's a little baby way of doing it. We don't want to do that. We want to get away from doing that. We don't want to just get x values, find our y values, and then put it in. What we're looking for is that you need to know your basic shapes of curves. So what does a line look like? What does the equation of a line look like? So what does the equation of a parabola look like? And then what does the graph look like? Hyperbolas, what does the equation look like in the graph? Exponentials, exponential functions, absolute value function, log functions, trig functions. What do we get when we do these? And what do our graphs look like? So we're looking for basically that. What's the idea of finding the value? What's the graph look like? What's our critical values? Where does it go through the axes? Where does it turn? And then being able to graph it up from that. So that's what we're going to be doing as we go through. And you've got to learn them well, because what we expect you to see in the course is to be able to see an equation, know exactly what a graph would look like. So what's its shape going to be, because you know if it's a circle, semicircle, hyperbola, parabola, or any other graph. So be careful of making sure you learn what the general form of all those graphs are, so we can attack them anywhere throughout the course.